Welcome to Math 63, Unit 2, Lecture 2, Part 2. We'll be simplifying some exponents.
Okay, here's an example of a exponent question from the textbook. Let's see if we can figure out how to solve this thing. Okay, so first off, there's a radical. That's what this checkmarky thing is called, right? There's a radical to the power of 4. Well, we learned from before, we had a rule that a to some radical n is the same as a to 1 over n, like that, right? So we can use that to say, okay, this is just 5 squared times 25 cubed to the power of 1 over 4. Okay, cool. Now we could, we could distribute. So we could distribute this 1 over 4 to both parts of, to both factors of this multiplication here. So the first one, we have 5 squared to the power of 1 over 4 times 25 cubed to the power of 1 over 4. Okay, I should point out, I am doing this using one way. There are multiple paths to take here. That this 25, right, you could say, oh, that's 5 squared, and then say this is 5 squared cubed, all that sort of stuff. If you want to do that, go ahead, do it. You'll get the same answer I do. Okay, we're just going in different directions, and that's okay. So now what I have, I want to multiply my exponents. So this is going to be 5. 2 times a quarter is 1/2. And now I have 25 times 3 times a quarter, which is 3/4. Okay, so right now I have two different bases, but 25 is nice. I can factor that and turn that into 5 squared, and then I would have at least something to work with. So I have 5 halves, not 5 halves, 5 to the power of 1/2 times 5 squared to the power of 3/4. So once again, the exponents here can multiply, and so I have 5 to the power of 1/2 times, now 2 times 3/4 is 3/2. So this is going to be 5 to the 3/2. Okay, yeah, 3/2 could be written as a mixed number, but when it comes to exponents, we're going to keep things as improper fractions if they're exponents, just because otherwise it would get really confusing. All right, so now we've got two numbers with the same base, so I can consolidate them and add the exponents together. So 1/2 plus 3/2 is 4/2, otherwise known as 2. So this all ends up being 5 squared, which we could rewrite as 25. That's one way to do this. There are probably more. If you can come up with them, awesome. All right, just looking here, we could have taken 25 from the beginning and called that 5 squared. So this would have been 5 to the 6 times 5 squared. So that would have been 5 to the power of 8. We might have been able to do this faster. Okay, so there's some practice for you. Figure out what's the fastest way to do this. All right, if you want to do that. Sounds good. All right, let's look at another example. Okay, here's another example. We have 10 to the negative 3/5 times 10 to the 4/5, all of that divided by 10 to the 2/5. Okay, so there are a number of first steps I could do here. I'm going to decide to use the rule, if I have the same base, I can then add the exponents. So this is going to be 10, and I add negative 3/5 plus 4/5, all over 10 to the 2/5. Okay, so negative 3/5 plus 4/5, that's 10 to the 1/5. All right, and then over 10 to the 2/5. Okay, so now I've got same base, but I'm dividing, so that turns into a subtraction. So this turns into 10 to the 1/5 minus 2/5. So that gives me 10 to the negative 1/5. Okay, so I could then rewrite this as a fraction, saying 1 over 10 to the 5th, which I could rewrite as 1 over 10 to the 5th root of 10. And to go anywhere beyond this, I'm going to need to pull out the calculator. Okay, so I need 1 over 10 to the 1 over the 5th root of 10. Or maybe I could just type in 10 to the negative 1/5. That sounds like it would be an easy thing to do in a calculator, so let's try it. 10, and I'm going to go press the exponent button, and I want negative 1 divided by 5. And my brackets. Okay, and so this gives me 0.6309573445, depending upon how many significant digits we want. There we go. We have an answer. All right, I do want to caution you, though. There are some common mistakes that happen with exponents that I don't want you to fall into these traps. So, for example, exponents do not mix well with addition or subtraction. So let me show you some examples. For example, if you were asked, hey, what is 3 cubed plus 3 squared? Okay? A lot of people would be very tempted to add the exponents and say, oh, it's 3 to the 5. No, that's a plus. Okay, so we're not able to do anything with this other than just to expand it to say this is 27 plus 9. And so that gives me, what, 36. Okay, it's not 3 to the power of 5. That's an entirely different number. Okay, another example is 6 to the power of 2 minus 4 to the power of 2. Now the exponents are the same, but we're not able to do anything because we've got subtraction here, and exponents and subtraction don't mix. The only thing that we're able to do is expand this into actual numbers. 6 squared is 36. And then 4 squared is 16. 36 minus 16 is 20. Okay, and that's what we do. So there's no connection between the exponents here and the addition. We just have to, there's no special tricks. You just have to actually perform the exponentiation. All right. Very good. I think that covers everything I want to cover for lecture 1 of Unit 2.